you will frequently encounter many abstract ideas, concepts, or beliefs. For example, in the field of psychology, you may have social psychology, halo effect, memory, etc. Explaining an abstract concept or notion is not as easy as explaining a real and physical object. When we explain a notional meaning, we are supposed to remind ourselves that it is not isolated. A notion can be related to many other ideas, concepts, or beliefs. Relationships between two notions are also different. It could be a causal relationship, one notion is the cause of the other, or an inclusive relationship, one is included in the other. Or it could be an opposite relationship, one is against the other. Identifying these relationships will help us express a notional meaning in a more understandable and explicit manner. Different relationships play different roles in explaining a notion. Generally, these relationships will provide a clear outline for writers to present a notion and a clear structure for readers to obtain information from the explanation. For example, Tu Hao is a Chinese word. When explaining it, we may think about who refers to and why this word is used to describe the people. In this way, we unconsciously relate the notion, effect, and the typical people, cause, in causality. Next, we may expand the notion by applying it to some social occasions and phenomena. At this point, I'd like to elaborate on how different relationships function in an explanation. Causal. Usually, when we are trying to explain a problem, a phenomenon, or an event which is more concrete and realistic, causality will help to answer where it comes from and why it comes into being. In addition, causality helps to explain what it will cause. Inclusive. We come across this relationship mostly in the academic fields. When explaining a mathematic notion, we usually use a tree graph to facilitate understanding. In daily life, we also use this relationship to divide and categorize things. Opposite. We may need to introduce some typical features when we are explaining a notion. But what can we do if the features are really hard to describe? Making a comparison with the opposite item will help. However, in order to be more academic, especially in writing, a scientific and concise description is needed after the comparison. If you are stuck in the start of a notional explanation, try to consider how the target item is related with other things. Another effective strategy in explaining a notion is explaining it analogically. An analogy is a comparison between two things, usually for the purpose of explanation or clarification. It aims to explain one thing by comparing it to something that is familiar. In popular terms, analogy is about relationships. There are endless types of analogy as the relationships between ideas and notions are numerous. For example, part-whole analogy, as in toe is to foot as petal is to flower, tool-worker analogy, as in sword is to warrior as pen is to write. We can see from the examples that an analogy is a comparison between things with similar features, often used to help illustrate a principle or idea. By analogy with something concrete and familiar, we can't infer the features, functions, or other elements of an unfamiliar or abstract concept or notion. As Freud suggested, an analogy won't settle an argument, but a good one may help to clarify the issues. Analogy is a practical method with many merits. The features of an effective analogy are, on the basis of an exact or similar idea, simplicity, clear embodiment of the concept or relationship between things. Metaphors and similes are tools used to draw an analogy. Therefore, analogy is more extensive and elaborate than either a simile or a metaphor. We can not only apply analogy to two similar items, but also to other things which are rather divergent from each other. An analogy is an important tool in problem solving and reasoning. In academic contexts, it helps in constructing and explaining rough theoretical notions by visualizing the notion. An example is Niels Bohr's planetary model of an atom's electronic levels. It drew an analogy between the solar system model and the electrons revolving around the nucleus of an atom. Another is an example of Claudia Caleb's analogy of memory to the RAM on a computer. It enabled a clearer understanding of notions, short-term memory and long-term memory. With flexible usage, we can jump out of the rules that the deductive method should follow. With creative imagination, we are free from the limit of the number and the type of the items that we choose. Try to think and explain analogically when you have complicated notions to deliver. It will be of great help.